There are so many ways that we can treat the earth well, especially through reducing our carbon footprint and recycling. Countless boxes and bottles and cans are transformed into other products that we see in our everyday lives. Millions of waste tires can also be transformed into safe, productive uses.
In California, the problem with recycling tires is once a waste, always a waste. And we see such tremendous opportunities on the forefront to use these tires for rubberized asphalt concrete and tire-derived aggregate.
Over 40 million tires are discarded and replaced each year in California alone. Most are reused in a variety of ways, from retreading truck tires to asphalt roadway additives. Millions still end up in landfills or abandoned in remote areas. These waste tires are a threat to the health and safety of our citizens, creating vector hazards and potential health risks if burned. Tire-derived aggregate, better known as TDA, is a major reuse for these waste tires.
By using the TDAs, we've been able to solve an engineering problem and also save taxpayers dollars because it was a less costly solution to the engineering problem that we have. I think it's also a huge advantage for Caltrans, and we're very excited in moving forward and using TDA material in the future because it's always good to use used up tires before they go to the landfill.
Many of these waste tires can be put to a safe, cost-effective use by simply converting them to TDA.
Tire-derived aggregate is made by running waste tires through a tire shredder. The material goes through the shredder, is then run across a classifier, where the pieces that meet spec drop through and are loaded into a truck. The material that is too large is recirculated back into the tire shredder until it meets the spec between 6 and 12 inches in size.
Today, mountains of TDA are loaded onto large trucks for delivery to many construction sites throughout California. TDA has a variety of uses that are a very effective substitute to traditional gravel and lightweight fill. Dr. Dana Humphrey has been researching TDA since 1993 and is the leading national expert on the material.
Tire-derived aggregate in roadway can be used as lightweight fill for embankments built on weak, soft ground. This could be for a landslide. It could be through a wet area. We take and use it as a drainage layer beneath roads. And when we're someplace where it's cold, we can take it, use it as an insulating layer to limit the depth of frost penetration. Next to the roadway, many times we have to build retaining walls, and we can use tire-derived aggregate as lightweight backfill for retaining walls.
TDA can also be used in landfill gas and leachate systems to help control moisture and landfill gas issues.
When we use tire-derived aggregate in landfills, primarily we're taking advantage of its high permeability. We can take and use it at the bottom of the landfill as part of the leachate collection and removal system. We can use it as part of a leachate recirculation system in the waste itself. We can use it as the aggregate around gas extraction systems, and then finally we can use it as part of our cap. So what we're doing is we're taking and using the tire-derived aggregate in place of conventional processed gravel.
TDA has been used successfully to dampen vibration on light rail systems.
The vibrations go through the ground and reemerge as noise in the homes and businesses adjacent to the track. By taking and putting in just 12 inches of tire-derived aggregate, we're taking and basically cutting off that path for the vibrations. And this is a very big deal for the people that live next to the tracks because, especially on a commuter rail line, you can have trains go by every 15 minutes, and it can be quite annoying.
The TDA solution is both cost-effective and helps to promote a cleaner environment. CalRecycle, a state agency, manages a waste tire program combining research, education, and market development to help promote TDA as a solution to civil engineering problems.
CalRecycle provides opportunities to promote and market tire-derived aggregate. We work directly with local governments to assist them in looking for grants to utilize tire-derived aggregate. And then we go one step further. we provide the engineering support during the project to make sure that this is a positive experience for them in the end.
Getting contractors and municipalities on board is essential to a successful TDA project. They need to understand the performance and cost benefits and how TDA is used in a particular civil engineering application.
Tire drive aggregate has been difficult to get accepted into the engineering community up until the last couple of years. Up until now, civil engineers have been dealing with conventional lightweight aggregates, and they felt comfortable with that. There were some unknowns using this new material, and so there was a reluctance to use something that was new. Recently, we've had numerous projects that have been very successful, been cost-effective, and engineers are now understanding that this is just another material that can be used to solve their problems.
What I'd really recommend is before a contractor does their first project with TDA is to sit down with an engineer who's worked with the material before and just go through the basics of how to work with this material. Because what we want to have is we want to have the contractors have a successful experience, because if they have a successful experience, the owners and engineers are going to be happy and they'll continue to use the material.
Let's look at an example of TDA use in Sonoma County, California. On Sonoma Mountain, a narrow road failed and was repaired 3 times in the past. The big problems were weak soil and poor drainage. The plan was to dig out over 30,000 tons of sliding earth. This is about the size of a 6-story building. First, the engineers had to develop a repair design that was stable and would not become saturated every winter.
The problem with Sonoma Mountain is that there's a massive excavation needed to do a traditional repair, which would be a repair with soil. You would basically have to cut out half of the mountain, and the biggest cost in construction is excavation. Because you're able to use a lightweight material to reduce the load and reduce the forces pushing on the underlying material, you can then, with the right analysis of stability and the right design and lightweight material, you can then limit the amount of excavation needed to repair the road. And excavation is a very expensive portion of a road repair, is moving dirt and taking dirt out.
330,000 waste tires were turned into TDA and used for fill. The project's contractors chose TDA because of its ease of use, its lightweight structure, as well as the fact that it has good drainage properties. These recycled tires now have a new life and purpose as a road fill material. They are helping to achieve an engineering solution on this mountain road.
When we're using tire-derived aggregate as lightweight fill for embankments, the first step is we lay down a piece of geotextile to act as a separator between the underlying soil and the TDA. Then we take and have the TDA delivered in what's called a walking floor trailer. The TDA comes out of the back of the trailer. The contractor spreads it with a bulldozer, spreads it in a 12-inch thick lift, and then goes over it with 6 passes with a roller that weighs 10 tons. So what we really have here is the same procedure a contractor would use to build a regular embankment. Then we can take and keep going up in 12-inch layers until we get to a maximum thickness of 10 feet, put another layer of geotextile, put 2 feet of low permeability soil cover on top, and then the remaining embankment and finally the roadway surface. And a big advantage with tire-derived aggregate over conventional soil, there's no need for moisture control. So you don't have to add water, so if it's a perfectly bone-dry day, use it. If it's raining, use it. Contractors like working with tire-derived aggregate. You can dump it out of the back of a truck, spread it with a bulldozer, go over it with a compactor. That makes it very, very easy for the contractors to work with the material, and overall they like it.
This is Palomino Road, a roadway that has failed in Santa Barbara County. It was unsuccessfully repaired several times in the past.
This road has failed several times over the past years, so it's been a problem child for several decades now. In 2005 as well as 1995, we experienced some settling on this roadway.
This road was built on a grade with expansive soils in a populated area that gets lots of traffic. Each time this roadway has failed, the families living in the houses below were in imminent danger of a landslide. The county realized this and knew they needed a more permanent repair using TDA.
The Palomino Road project demonstrates a common roadway failure in California and in parts of the nation, where you have underlying materials, clay soils usually, that are very poor. That particular road was in a neighborhood and there were houses adjacent to the road downhill which could have been affected had the road completely failed and slipped down the hill.
Cal Recycle worked with local county officials to make this road repair permanent. After digging out 6 feet of poor soils, geotextile fabric was placed and a standard road drain installed. 3 feet of TDA were added and compacted. By using this simple procedure, the local government in Santa Barbara has created a considerable taxpayer savings, because by using TDA, there were significantly less excavation costs than a conventional road repair project. Also, there were fewer traffic delays during construction.
The Palomino Road is a good example of a typical TDA repair for roadways where you're limited in space and you access the repair from the road itself. You only excavate down a maximum of 10 feet. You do the repair without accessing the side slopes or adjacent properties.
Using TDA was seen as a great benefit to the county because they did not have to acquire new land or obtain easements. Also, the surrounding private properties were undisturbed and Palomino Road remained open to traffic during the repair process.
I think in addition to having this new approach of using TDA to solve this reoccurring road problem that we've had on this stretch of the road, it's important to recognize that this is also helping the environment in a major way. We are taking 35,000 tires out of the landfill, recycling those tires, and using it for the filler that's needed for this stretch of the road to solve this road problem.
Today, Palomino Road will not deteriorate and slide away as a result of winter rains or heavy use. TDA has saved the roadway for the local taxpayers and improved its life expectancy by 300 to 400%.
It's going to increase the life of the road 3 to 4 times, we would think. So we're hoping for 35 to 50 years of life on this road using recycled tires.
TDA is now a proven alternative to some of the more traditional types of roadway repair projects. Also, the repair is more permanent and the result was quite cost-effective to the county. These tons of recycled tires have contributed to a true sense of safety and security for the homeowners living at the base of this slope and in the surrounding neighborhood. There are many ways to treat the earth well through recycling and improving our carbon footprint. Everyone can help keep California green. Tire-derived aggregate, or TDA, is a good example of how a waste material can be recycled to a higher use while being cost-effective and benefiting the citizens of California.
As a recycling professional, it's exciting to see the opportunities on the forefront at what we can do with previously waste materials. Tire-derived aggregate has a multitude of opportunities in front of it.
Well, I think utilization of TDAs by Caltrans is a huge benefit to the future of California by utilizing those waste tires. We've started that process, and I think into the future we'll take greater advantage of utilizing tires in TDA applications.
Well, I think Cal Recycle provides the innovation, the research, and the resources to make these types of solutions possible.
We installed over 3,000 linear feet of the TDA trackway, and the net effect of that was over $1 million in savings on our project.
The satisfaction for using tire-derived aggregate is to see the use grow from about 2 million a year to somewhere between 50 and 60 million per year. And this now makes a major contribution to how the United States manages its scrap tires.
This use of recycled material is a great benefit to our environment. Not only are we reducing the carbon footprint by using this material, but we're also limiting the use of natural resources.
I worked for 13 years to promote civil engineering applications of tire-derived aggregate. I'm proud of the progress that the state has made in developing the market and developing new applications that had never been thought of before, to truly find an environmentally cost-effective reuse for a very problem material.
So this is what it was like before TDA. Now this is what it's like after we use TDA. What do you think?